Today we're going to be talking about powers and exponents. And let's get started. We want to look at this figure and write the power represented by each model here. These are geometric models. Well, look at this. We have dots and they're arranged in a 3 by 3 pattern. And we can write that as 3 to the second power, or 3 squared. 3 squared is 9, and notice that's what we have, are 9 dots. Let's take a look at these blocks here. Well, let's think of what this looks like. It looks like we have figures that measure 3 by 3 by 3. 3 in the length, the width, and the height. So that would give us 3 to the third. And notice that there are 9 blocks in each row, three rows, or I should say layers maybe. 9 blocks in each layer. 3 layers, and so that would give us a total of 3 to the third, or 27 blocks. If we look at this figure, we've got 4 squares. This is arranged as a 2 by 2 pattern, so we would write that as 2 squared, and 2 squared does give us 4, so we get our 4 blocks. Now, the next thing we want to do is let's take a look at some of these expressions where we are asked to simplify. Now, if we have negative 6 to the third power, and the negative 6 is in parentheses, this means negative 6 times negative 6 times negative 6. So we want to think about this. First of all, we can do 6 times 6 times 6, which gives us 216, but now we have to decide on the sign. Well, a negative times a negative gives us a positive, but times a negative again gives us a negative. And actually, when we have an odd number of negatives, that gives us a negative. Now, when we have an even number of negatives, that is going to give you a positive. Okay? There should be an I there. Okay. All right, so now let's take a look at this next one. We have negative 10 to the second power. The negative is not in parentheses, okay? The exponent only applies to the quantity immediately in front of it, which in this case is 10. It's not what's in parentheses. So all this means is we're just going to drag that negative along, and then we're going to say 10 times 10, which gives us 100. But remember, we're dragging the negative along, so we get negative 100. All right? Now let's say we have 2 ninths squared. That means we're going to say 2 ninths times 2 ninths. So we can't cancel anything. Let's multiply right across, so we get 4 over 81. Let's try this next one. We have negative 5 in parentheses to the third power. So we have negative 5 times negative 5 times negative 5. Because the negative's in parentheses, it's going to get multiplied each time. We have 3 negatives. That's an odd number, so that's going to make our answer negative. And then we're going to say 5 times 5 times 5, which gives us 125. So we get negative 125. Now, let's take a look at this next one. We have negative 6, not in parentheses, squared. So this, again, means we're just dragging along the negative, and we're going to say 6 times 6, which gives us 36. But again, drag that negative along and put it in front, so we get negative 36. Now, let's say, I know it's not written down here, but just say, for example, I had negative 6 in parentheses squared. That would have meant to say negative 6 times negative 6. Now, a negative times a negative gives you a positive. So we have a positive 36. If the negative's in parentheses, it's going to be multiplied. If not, it's just going to be dragged along. Okay, so let's take a look. We have 3/4 to the second power. So that's 3/4 times 3/4. We can't cancel anything. So 3 times 3 is 9, 4 times 4 is 16, and we get 9/16. Let's move on. it says write each number as a power of the given base. Now, basically what we're saying, you're given the number 64 and a base of 8. So we're saying 8 raised to what power gives us 64? This is what we're looking for, is the exponent. Well, 8 raised to the second power gives us 64, 8 to the second. Now take a look at this one. We're saying -3. Great. And since it's -3, we're going to put it in parentheses. Raised to what power gives us 81? So you want to think -3 times -3 times -3. Well, let's see. -3 times -3 is 9. Times -3 again gives us -27. Times -3 again gives us positive 81. We had the -3s there 4 times. So our missing number was 4. That was our exponent. So let's try this next one. We have -3 raised to what power gives us -27? Oh, look at this. We can go back to the last problem. Well, -3 times -3 times -3 gave us -27. So we multiplied, we did that 3 times. So our missing number was 3. That was our exponent. Next, 32 and base 2. So we're saying 2 raised to what power gives us 32? And you can start multiplying. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And so we have 5 2's, so it's 2 to the 5th. 5 is our missing number. Okay, in this next problem, in case of a school closing, the PTA president calls 3 families. Each of these families calls 3 other families, and so on. How many families will have been called on the 4th round of calls? Okay, well, you can think of it, you start off, you got 3 families, then each person calls 3 other families. We aren't going to draw this whole thing out. But and so on, and then it goes from there, you can see. And we want to know how many families will have been called on the 4th round of calls. Well, another way of doing this, rather than drawing a diagram, which is a fine way to do this, is to use powers. So we could actually do this. Each family calls 3 other families. There are 4 rounds, and we can write this as 3 to the 4th power. So that's 3 times 3 times 3 times 3 times 3. Well, that gives us 81 families. Okay. Well, thank you very much for joining me today.